My name is Patrick Boo. I'm the product manager for the service port framework. And I'm going to show you the new LoopTune Accelerator service that we have in service port. That is the companion for the loop performance channel. So let's start with the loop performance channel. It's monitoring the performance of up to 1,000 control loops at once by taking the measurements and actually calculating what could go on with it. So it will detect if you have a valve that is sticking or if you have over control. So if we look at an over control issue here, we have a couple of devices with over control, and I select one of them and I get to the data view, and here we can clearly see over control taking place where the measured value, the green one, is fluctuating and trying to stay at the purple one, which is the set point. The control output is of course chasing as well, so this one is clearly over control. Historically, you would ask then the operator, can I please do a bump test? Can I affect the process in a way so I can get useful data back to do a modeling to come up with better tuning parameters? But the data we have in the loop performance channel probably contain one of those bump tests already that happen naturally. So the Loop Tuning Accelerator service, or the LoopTune channel as it's called in service port, is just a quick list of the different loops that have a naturally occurring step or a bump. So if you have a problem with a device and you look here and say, oh, I actually had an occurring bump, you can use that to tune your loop. So here we have a clear bump when the set point went from 10 down to 8. The green one, which is the measured value, followed nicely. So this is a perfect candidate for the loop tuning part of the Loop Tuning Accelerator service. So when you detect something like this, you select Extract Data into LoopTune, and you will call up the LoopTune Workbench tool, which is automatically installed with the LoopTune Accelerator service. So this tool, we already loaded the file, so now we need to do a configuration, and if you've done the loop performance channel correctly, the configuration is already done for you. But you should verify that the set point is to the set point, measured value, and so on, and the limits here. But we are pretty good with this because we did the loop channel correctly, so we can go directly to identify a process model. And what we do here is trying to build a mathematical representation of the real world. This blue line goes into the mathematical model, and the black line coming out should match the pink one as closely as possible. This is not bad, but it's not great. But on the other hand, we're only interested in the bump over here. So I will actually zoom in. Okay, so we can use the tool to automatically try to identify the mathematical function that goes to present the real world. And by clicking just that button here, we see now that the black line is overlaid the pink one much, much closer. And we can also see that we have an RMS error on the other side of the screen here that is quite low. So once I feel this is good, and I can change the parameters myself, but the software makes a pretty good job of it, I can go to the tuning of the loop. So I can use my model and tune to see what would happen if I do different settings. So right now it have some PID parameters already pulled in, and we can see that a set point change of the black one here will result in the measured value of the pink one, so it catches up pretty quickly. It's not bad at all. So we can now punch in whatever parameters we would like here. So we do a gain of 10, and I want the integration time 1, and I will click Update, and these pink lines will then change. And here we see they change and respond really quickly, but they are overshooting, and it takes a bit of time until it stabilizes. And if you did this in a real process, it would not be good. You could actually damage equipment. So that was a bit too aggressive. So I will a gain of 2 and a much more relaxed integration time of maybe 25, and then do update again, and we will see the pink line is quite nice now. It responds really quick, comes up to the black, it doesn't overshoot. These are pretty good numbers. So what I would do now is to say, okay, I have a gain of 2, integral time of 25. Let's go to the process and see what's going on there. If the settings, actual settings in the factory, is somewhere in the neighborhood of these numbers, I should probably go and put these in and see how it will affect the process, if it will be a better result. I can generate a report as well to have a support. What did I do? What did I select? What was the result? It's a really powerful way of keeping track of what's been done. So after I put these values in, I can go back to my channel, and the next time we collect data, I will actually see if this change I did, how it affected things, because the loop performance channel will keep measuring that. So that's the Loop Tune Accelerator module, which is a companion for the loop performance channel to do your loop tuning and to collect this data so you can eliminate the need for destructive loop bump tests in the process. Thank you very much.